Hello, I have a question here, which has come off a website called Enrich. That's the letter N, RICH dot maths dot org / 5963. Now, the question that's been given to me as a challenge by a friend of mine called Chris, who is a mathematics teacher himself, is this. It says a mathematician goes into a supermarket and buys 4 items. Instead of adding the prices, she multiplies them in decimal pounds. For example, £3.12 times 0.72 pounds, and so on. Her answer is £7.11 or £7.11. At the till, she says, so that's £7.11. The tillman correctly adding the item agrees with her. So we also add them and we get the same price. And the question is, what were the 4 prices? Well, the only way that I can think to do this, and it took me quite a long time to think of a solution, and let me get my paper. So it took me quite a while to think of a solution. And as I see it, there are 2 ways of doing this. The first way is to suppose that 2 prices are the same and the other 2 prices are the same, but the sum of those 2 different prices is different. The other way, the way that I actually chose and worked everything out, was to let 3 of the prices all be equal, and I really can't think of another way to do this except by trial and error. So I'll go through the way that I chose, and hopefully this will be the right method, but it might be wrong. There might be another method. If you can find another method, by all means, go for it. So basically, we're told that 3 prices, W, X, Y, Z, or the product of 4 prices, is equal to £7.11 or £7.11. And we also know that the sum of all of these prices is £7.11. Now, what I did was I said, let X equal Y equals Z equals A. Okay, so if we call that equation 1 and that's equation 2, equation 1 gives WA cubed equals 7.11. We'll call that equation 3. And in fact, I'll just make a little bit more room on the board up there because I might need the other half of the board. So we've got equation 1, 2, and 3. And substituting A in for X, Y, and Z here, we have W plus 3A equals 7.11. Well, so that's equation 4. Now then, what we do is from equation 4, we have, let me see, W is our first price. We'll assume that is the largest price. So what we've got is 3A equal to 7.11 minus W, and we divide both sides by 3 get that. Now, substituting, so we'll call this equation 5. Substituting 5 into equation 1, we get, or rather substituting equation 5 into equation 3, because that's the modified version of equation 1, we get W times 7.11 minus W over 3 all to the power 3, and that is equal to 7.11. Let's make that look more like a 7. Okay. Now, if we go from this equation to the next line, how are we going to solve this? Well, if you multiply all of that out, you'll end up with an equation in terms of W to the power 4 plus or minus W to the power 3 and so on like that. So it will be I think they call it a quartic equation, which will be very, very difficult to solve. But there is something else we can do with this. You might have heard of the process of iteration. Well, we can put this into a form where we can iterate the solution each time and get a better and better, more accurate value of W. So, what we do is we write 7.11. I'll just draw a dividing line down there. Minus W to the power 3. 3 cubed is 27. And we're going to divide both sides by this W here. So we've got equal to 7.11 over W. Right? So dividing both sides by W first, we get 7.11 minus W over 3 all cubes, and that's equal to 7.11 over W. We've already cubed the 3, which is 27 up here, and then what we do now is multiply both sides by 27, so that becomes 191.97 over W. Now what we can do is we can take the cube root of both sides. So we've got 7.11 minus W is equal to 191.97 over W to the power a third. Right? We can simplify that a little bit. Well, certainly for the purposes of putting everything into our calculators. Or you could just leave it like that, really. So what we've got is W is equal to 7.11 minus, I think I will leave that as it is. Otherwise, you end up with numbers that go to many more decimal places. I don't tend to be irrational or transcendental or something like that, you know. Right, okay, so what we do now is try a value for W, and what I mean is the W that is in the numerator, the denominator of this part of the fraction, not this. This will be the new version of W that we get out of this. That's the value that we choose to substitute in. So I chose 5. Say 5. Thus, we have W equals 7.11 minus 191.97. We'll put the power of a third in there, over 5. And that comes out to be equal to 3.736. 3.736 to 3 decimal places. Now, if we substitute this back in, well, if we substitute this back in for W, back into here, we find that we've got W equals 7.11 minus 191.97 all to the power of third divided by 3.736. And that comes out to be equal to 3.392. Then, once again, we'll call that W1, W2, W3. So now we've got 7.11 minus 191.97 over 3.392 to the power a third, and that comes out to be 3.271. Then we try for a lower value. So we get 7.11 minus 191.97 over 3.392 to the power 1/3, and that's equal to 3.22. So it's coming down more slowly now, as you might notice. It's beginning to converge. So W5 is equal to 7.11 minus 191.97 over 3.22 all to the power a third. And that's equal to approximately 3.19. You can go a bit further down than that, but we'll stop at 3.19 because that is the kind of the more or less convergent value of what that iteration process is. Now then, what we've got is an approximate value for W. So let me just rub this part of the board off. There we are. So, what we can do now is therefore we let W be approximately equal to 3.19, or just say W is equal to 3.19. This means that equation 3 becomes, and it's easier. I'm choosing equation 3 for this, but you could resubstitute everything into equation 4 and you should get the same values. So we've got 3.19 a cubed, which is equal to 7.11, right? So dividing by or both sides by 3.19, we have a cubed is equal to, and what did I get? 2.2274. Taking the cube root, a is equal to the cube root of 2.2274. So a is equal to 1.31. This means, and I'm going to clear the other side of the board now. This means that x equals y equals z equals £1.31. How do we know we've got the right values? Well, WXYZ is equal to W, and XYZ here is just equal to a cubed, because x equals y equals z equals a. So if you substitute a in there, multiply it by a, multiply by a again, you get a cubed. So you get a cubed w. And what we can write is, well, we said w was equal to 3.19, and a cubed is, well, we can just take this value here. We don't even need to take this and cube it again. So we just multiply by 2.2274. I'll write it in for you anyway. 1.31 all cubed. So we've got 3.19 times 2.2274. And what does that come out to be? Well, you can check this on your calculators, but it comes out to be equal to just about 7.11 pounds. But does it add, do all those figures add up to give 7.11 pounds, as in equation 2 here? Well, if we substitute x equals y equals z equals 1 point, just a moment, 1.31, then we have w plus, I should have said, so if you substitute x equals y equals z equals 1.31 into equation 2, for example, then we get w plus 3 times 1.31. But we know what w is, don't we? So what do we say w was? 3.19. So if we substitute x equals y equals z equals 1.31 and w equals 3.19, into equation 2, then we've got 3.19 plus that, which is equal to roughly 7.11 pounds. And that is one way of doing it. I'll just quickly say another way that you could try is to let w equals x equals a and y equals z equals b, right? So that you get a squared b squared equals 7.11, and then here you would get the sum would be 2a plus 2b equal to 7.11 again, and you would have to rearrange that and substitute in for a or for b. What you would get either way is a cubic equation out of it, and then once again you could either try solving the cubic equation, which might be a little bit tedious, long-winded and involved unless you have mathematical software to help you, but you would then find that you'd have a value for a and a different value for b, so that you'd have two identical values in one instance and then two identical values in another. So in other words, there'd be two pairs of identical, have I got that right? Altogether, the person who walks into the shop buys 4 items. 2 of those items would be equal to one particular price each. It'd be the same price, and the other 2 articles would also be identically priced per item, but would be different to the first 2. So anyway, you could try that method. So I'll leave that one, that second part, for you to have a look at. Again, an iterative process might also work with this. So we'll leave it there, but I hope that's helped, and thank you very much, and see you soon.